Hey guys, it's Mr. Win, and I'm going to talk about Unit 2, Section 4, Quadratic Functions in Vertex Form. Now, there are many reasons we use vertex form, and one of them is we can easily tell how the graph looks just by looking at the equation. We can tell the vertex, the axis of symmetry, and how it opens, all right? This vertex form may look familiar. It's something we dealt with in Unit 1 transformations, where we had our A, H, and K, how they transform that equation, okay? But in this case, there's a squared in our parentheses. That means it's a quadratic. So it's a vertex form of quadratics, all right? I have an example here, all right? Notice how the 2 is going to be your A, all right? The 3 is going to be your H, and the negative 4 is going to be your K. To get the vertex, all it is just the H and the K. So your vertex, right, is just your H and your K as a point, because the vertex is a point. It's the point where the graph changes direction. So here your H is 3, but remember our equation says negative H, so it's always the opposite of what you're given. So instead of 3, in this case it will be negative 3. And then your K is always the same. It's just negative 4. It stays the same, right? So that means the point we put on the graph for the vertex would be at negative 3, which is here, and negative 4. Here is our point. All right, excuse that little point there. Let me make that look a little better. Here we go. There's our vertex. All right. And then we're also able to tell the axis of symmetry. Your axis of symmetry, I'm going to abbreviate it as AOS, is just going to be x equals whatever your h is. And in this case, the h was negative 3. Just remember that axis of symmetry is a line. It's an axis. So it does have to be, it does have to say x equals. So our line would just look something like this. X equals negative 3, right? That's x equals negative 3. That's also your axis of symmetry. And lastly, you're also able to tell if the graph opens up or down. In this case, we just look at the A. And our A here is positive, right? Because it says A is greater than 0. When it's positive, it's going to open up. If it's negative, it will open down. All that means A is greater than 0. That just means positive. A is less than 0. That just means negative. All right, so we know the graph opens up. We know it probably looks something like this. All right, we have a general idea of how the graph should look. Okay, let's actually solve a quadratic from standard into vertex form, so we're able to use this information, right? Tell the vertex, axis of symmetry, and all that. All right, here's the problem. Negative 3x squared plus 24x minus 43, okay? The last part of section 4, we did completing the square. That's how you're going to solve these problems, all right? But notice there is a number in front. So completing the square, a little bit different. There is a number in front. I'm going to show you what to do. So first off, you do need to cancel the c. That was what we did on completing the square. That's how we solve. But in this case, this is a little bit different. We don't quite cancel the c, but we're just going to put it to the side and deal with it later. So I'm just going to let's just group the first two terms. Okay, and then leave a little bit of space, and then I'm going to move my c out to the side. All right, so I'm grouping the first two, I'm moving the c out, because remember, completing the square means I'm going to choose a number here that gives me a perfect square as my factors, okay? So I can just write 1 and just write a little square on top, okay? So we were choosing a number that works out nicely, okay? That gives us the same number, right? We get to choose. We're kind of forcing it to where it factors easily, all right? That's why I move away the c, and I'm going to pick an even better one, all right? The way to do that, you do have to make sure x squared is alone. That was the next step, and it's not. So that means I have to divide out. I have to cancel out this negative 3. So divide out negative 3 to both of these, all right? That negative 3 does now go in the front, okay? It still has to stay there. It has to stay balanced. But now at least I have x squared, and 24 divided by negative 3 would be negative 8. So instead of writing plus, let's write minus 8x. Okay? Leave a little blank again, and here's my negative 43. Now to find out what number goes here, we do that little formula. I'm going to do it to the side where we do half of b and square it. And in this case, our b is going to be negative 8, right? So let's take half of that, negative 8. And I'm going to divide that in 2, which would be negative 4 and then squared, which should give us negative 4 squared, negative 4 times negative 4, a positive 16. So the number we're going to put in here is going to be plus 16. All right? But again, the next step is to keep everything balanced. So if you're adding 16 to one side, right, you've also got to add 16 to the other side. That's what we did on the last assignment. But remember here, we're doing it on the same side, right? So to keep it balanced, to make it stay the same, if I have plus 16, I'm going to have to subtract 16 to this number as well. Think of it like this. Okay, I'm going to draw a little example. If I have a little, let's say a little balance here, a scale, right? Here's my nice little scale, right? And I put plus 16 to one side, right? Now, it makes sense. You know, this scale would start going down because it's heavier, right? But if I put plus 16 here to the other side, yeah, it stays balanced, right? It stays even. But again, we're working with the same side because remember, our equal sign is out here, right? It's f of x equals. So we don't want to add 16 over here, right? You don't want to do that because we're going to leave it as f of x. That's our vertex form. It's supposed to be a function of x. It's supposed to stay f of x. So instead of writing plus 16, let's erase that, right? Let's subtract 16 to the same side. Let's keep that consistent. And then it'll be 0. It stays balanced, right? But here's the thing. I put the plus 16 inside of parentheses that is being multiplied by negative 3. So not just plus 16, right? What we're really adding is negative 3 times plus 16. In that case, I have to do negative 3 times negative 16 to the outside, right? So not only are we subtracting negative 16, I am also going to multiply that by negative 3. Ooh, I did not see that mark there. Let me just clean this up a little. I apologize, but this is what I had. All right, and then I'm going to do that math problem out, okay? That is a 16. All right, so now if I rewrite my problem, I got f of x equals, let's just say negative 3x squared minus 8x plus 16. Negative 43, negative 3 times negative 16. Do that out first. That should give you a positive 43. So we're actually adding 43 to negative 43. Oh, excuse me. No. 48. I apologize. 48. I'm adding 48 to negative 43. You would be left with positive 5. All right? So that's keeping everything balanced. Now we got to figure out this part here where we're finishing completing the square. But completing the square, remember, we chose 16 on purpose. It's a good number because if I were to do the whole diamond factoring, that x method, I would put 16 here and negative 8 here. You end up with the same numbers because negative 4 times negative 4 equals to 16, and negative 4 plus negative 4 adds down to negative 18. So those are the same numbers. So when we write our equation, it's going to be x minus 4, all right? But instead of writing both of those, let's just write one of them and square it, right? So in this case, our vertex form ends up being negative 3 x minus 4 squared plus 5. That looks exactly like A, H, and K, right? It's now in our vertex form. Completing the squares puts us at parentheses squares, so we'll leave it like that, and that's our answer, all right? Just know your vertex would be the H and K. So in this case, the opposite of H, which was negative 4, would be positive 4. And K, your 5. Axis of symmetry is just your H, but with an X equals, so X equals 4. And then our A is negative, so we know it opens down. And that's it. Thank you.